All right, let's go for it. Now let's go for it. Okay, 1.6. So in any math book, you guys should probably seen it before, right? The last section of each chapter is probably the more difficult one. The same reason here, right? What we're going to do is we're going to talk about all the different methods at the same time. And at the same time, we're going to set some criteria, what it means to be fair. And so let's go for it first. So first things first, we got Dr. Arrow, I believe, or Mr. Arrow. So we examined 4 different voting systems. Ooh, can we name them? Plurality method, Borda counting method, pairwise comparisons, that's number 4, Yes, plurality with eliminations. Okay, so we got 4 ways we've hold elections, and for the most part, it's kind of funny because for the most part, that's the way everything works as far as from elections, right? There's a modification, right? To American Idol, to Voice, to that's it right here. Here's your 4 typical scenarios for how we do elections, right? In any situation, Heisman Trophy winners, whatever it is. Okay. So let's go for it. So we did all those. And the fundamental question was, which one's the best? That is it. Which one's the best method? Answer? None and all, I guess. I don't know. How do you answer that question? Because each one has their strengths, each one has their weaknesses as well, right? So this goes all the way back. Could you imagine all the way to the 1700s? That's where this kind of all started. 1700s, math took on a whole new realm in the public eye. Part of math was we started figuring out probabilities with math. Card games. We're like, hey, you know what? I can add some numbers to this. I could probably figure out how to count cards. I mean, it all started in the 1700s. That's kind of the fun part here. So math took on a social aspect as opposed to just being kind of like in the university. People are talking about it. Cool. So let's go back and let's talk about these guys here. Here's Bordeaux. Jean-Charles de Bordeaux, born 1733, 1799 died. But there it is, French mathematicians. He develops that method. But good, we've been using it ever since. And we used it in elections, right? Still need a guy to say his name here. I can get Nicholas, that's cool. Condorcet, I believe Condorcet. But is he French? He's French, so Condorcet. Because just like Chevrolet, you don't pronounce the T at the end, right? It's a French word. So Condorcet, I think. I'll look it up. I'd like watch a documentary. Okay, so then there's the 1940s, Dr. Arrow, Kenneth Arrow, he starts looking at these counting methods and he realizes, you know, what is fair? That's the question. What is fair? And so he stumbles upon some funny stuff here. So here's a picture of him in his prime and then as he gets older. These are all Wikipedia posts here. So 1921, he's born in New York and immigrates to Palo Alto, California. I don't know. What's in Palo Alto? Anyways, dies just what, 2 years ago? Just 2 years ago. Right, so he comes up with these criteria you have to meet in order for something to be fair. So let's go for it here. So fairness criteria. To answer the question, there's a minimum set of these requirements. We call them Arrow's fairness criteria. That's it. So we're going to figure out if things violate it or not. So 1.6, we're bunching all these 4 methods together, and we're going to talk about all 4 of them at the same time. So first of all, majority criteria. If there's a majority candidate, then the candidate should be the winner right off the bat. Done. If you have the majority criteria. Now, it works if there's 2 people pretty easily, right? You can have 52% versus 48. You're done, right? But once you get to 3 people, then that's a problem, right? Because then you have 3 people to choose from. Are you really going to get a 50% or higher vote out of 3 people? Usually not, okay? Even in the last elections, right? Trump still didn't get a, did he get the popular vote or no? No, he still didn't get a popular vote, right? So it was a split out vote, right? Between the Electoral College and popular vote. So it's kind of fun. These elections are kind of fun. Anyway, majority vote, everybody agrees with a majority vote? Boom. Okay, next. The Condorcet. criterion. Here it is. If there's a Condorcet candidate who beats all the other candidates, right? Pairwise. So we have to do a pairwise comparison here, right? At the cap of that. Then the candidate should be the winner. There it is. Done. Let's go through these kind of quickly here, and then we'll see. Okay, so there's that criteria. So if you have that candidate that wins all the head-on-head tabulations, that person should be the winner. We good? So majority, then this one. Okay. Monotonicity. Okay, this one's a little bit harder. Let's see. If candidate X is the winner of the election, then X would still be the winner had a voter ranked X higher than its preference ballot. Okay, so let's see. Okay, I see. Yeah, remember that. So because a person stands higher on the ballot system, there's no way for another person underneath it to come higher than them. There should not be a way to do that. That brings it up. Anybody know what system might break that rule? Which is the one that we talked about, like, that's kind of just intuitively, that's not fair.
Or no, is it? Oh, it's
elimination.
Elimination, because what happened during elimination?
Eliminate the last one.
Yeah, the last one gets eliminated, right? But then what happens is those point systems actually trickle up to the higher players, right? That's when like, what? That doesn't kind of make sense, right? So he's saying, look, if that happens, you went against this criteria. The last one here. Independence of irreverent alternatives here. So, if there were less people in the candidate pool, still should not affect the outcome at the end of it all. Okay, we're good there. Okay, so if anything violates any one of those four, at least according to Dr. Arrow, who had a Nobel Prize, so he's smarter than me. He's saying that's kind of, it doesn't qualify as fair anymore. That's kind of what we have there. Okay, so let's go with it here. So some examples here. So a little small election, here it is. The majority candidate election is A. Are we agreed? So popular vote. So plurality vote, we'll look at this one here. 6 is the highest column, right? Look at who's the first candidate, and we're done. Boom. Okay. However, we use the Borda counting method. Real quick here, if you start counting. So this would receive 4 points. Angel, you were here for this one, the Borda counting method? Okay, 4, 3, 2, 1, right? And you start counting points. Notice that B kind of stacks up higher, right? So A is the winner of the plurality vote. B is the winner of the Borda counting method. And so means that we have a violation, is that right? And so the question is, which violation is it? The majority violation. Notice that on the first count of things, that's 8, right? 9, 10, 11, right? Half of 11 is 5.5. So is 6 bigger than 50%? Yeah, so A should have been the winner, right? But then if you start counting all these point systems, B becomes the winner. Okay, we good? It fails the first criteria test. Okay, let's revisit this one. And these are all, we're revisiting all these ones that we did before. Okay, let's go for it here. Next, if you were to do this, not going to do it, but if we were to do this, if we were to go and compare pairwise comparisons between each one, so we start off with alphabetical order, start with F, compare it to these guys, right? We do all these pairwise comparisons. We'll find out that there's a, say it with me here, Condorcet, is that right? Condorcet candidate? Yet, if we look at plurality votes, This one's still points. Are we good? So just real quick, just go back, just make sure we've got this here. So to prove that a majority criterion is violated, right? Some person has to have more than 50% votes, right? And then we use another method, in this case the Borda counting method, and it violates that criteria. Okay? Let's go on to the next one here. One second, let me just see real quick. It violates the up here. So majority violated by Borda counting method is the majority issue. Okay. You have the Condorcet candidate and the plurality issue here. So you got that. That violates the Condorcet criteria. We're good. We're just gonna let's go through each one of these, and we'll actually get to each one here. So this one's a kind of important table here, and let's talk about this here. Here's your different criteria that we had before, right? And so if you're going to test something, whether it violates the other one, majority vote is technically the plurality vote. Those are two interchangeable, right? Those are two the exact same. Okay. So if you test this to violate this, it's not going to happen. The only time this can be violated is if you do a Borda counting method, right? Plurality says, hey, A should have won, but then do this method and you say, shucks, by the Borda counting method, the other guy wins. We're good? And so this is a table in which you have to use this in order to figure out if something has been violated. So Condorcet can be violated by the plurality vote, the Borda counting method, or the plurality with elimination. Let's go back up because we have to kind of get into the groove of things here. So real quick here, majority, whoever has the most points wins, right? This one is whoever candidate beats everybody by pairwise comparisons. But then when it does that, if that's the criteria set, then you go back to plurality vote, then it's not the same thing anymore. Okay? So this is majority violated by pairwise comparisons. Okay? This is pairwise comparisons are made, but then plurality messes it up. Okay? Or plurality with elimination messes it up. Okay? Monotonicity criteria. Let's see which messes it up here. This would be definitely plurality by elimination, right? Go here. That's the only thing that can mess this criteria up. Good? That's why this table is kind of important. Okay, and then last one. Right here. So what's the one that can mess this up? At this point, all of them can mess that up. Right? Anytime you get rid of a candidate, which things change. So really, plurality with elimination would probably be the easiest one to use. Okay. Yeah. All right. So this one just says, hey, first election candidate should be winning. Okay. Jump to here. Oh, okay. So here it is. Here's the fun part. So Dr. Arrow says that if you have 3 or more candidates in a pool, you're going to violate one of those 4 somewhere along the line. There's no way that you cannot violate any one of those 4 with 3 candidates. With 2 candidates, it was fine. Okay? 3 or more, you're going to violate one of them. Isn't that strange? You figure here's what fairness looks like, right? And then on the other side, he says, with 3 or more candidates, you're never going to receive fairness in an election. Okay, so this is the conclusion of the textbook. I don't know if I agree or not here. So it tells us no matter how hard we try, democracy will never have a perfectly fair voting system, and the potential for some form of unfairness is built into every single election. This does not mean that every single election is unfair, that voting method is equally bad, nor does it mean that we should stop trying to improve the quality of our voting experience. I'm not sure that's true. Because, of course, the fairness criteria is there, right? But I'm thinking, if you know the rules ahead of time, right? And you step in knowing the rules, and you did the election process according to the rules, and then the outcome is calculated, to me that feels fair. Does that make sense? And so, kind of separate fairness from like, this is the way it should be, as opposed to fairness according to the criteria. Cool. All right, so let's go with it here. Here's where my conclusion. Or actually, no, this is the book conclusion. I kind of put in my own little words here. So elections are going to happen no matter what, right? Every single reality show is going to probably give you some form of election if there's an election process there, right? We will always elect a mayor. We'll always elect a president, right? So they're going to happen. There are many different voting systems out there, as we've seen, right? Encapsulated down to 4. So that's the cool thing about kind of this chapter 1. All the different voting systems you ever think about kind of comes down to these 4. That's the way the process works. All right, different voting methods produce different results. We saw that, right? Plurality vote is different from our Borda counting method. And fairness in voting is usually elusive. At least that's what the book says, according to the fairness pieces there. Okay, I got 2 problems, maybe 3. Let's see how that goes, okay? So here's close to the homework. In fact, let's do 51. It's not part of your homework, right? But then since this is the day before the exam, let's actually do 53 and 57, which is part of your homework. Benefit of being in class today. How about that? Cool. All right, let's go for it. So, table 41 illustrates why the Borda counting method violates the Condorcet criteria. So we do have to do some counting, right? You guys ready to count? Let's see. There's 1, 2, 3, 4 of you guys. Good. Can we do some counting together? Yeah. Caleb, can you count points for A? Cool. Angel, points for B? Madison, Maddie, right? Okay, points for C. Jasmine, can you do points for D? Just real quick here, points for D. So remember, first place is 4 points, because if we're getting first 4 points, 3 points, 2 points, 1 point. Okay. All yours, give you guys a minute here. Or you might be done already. Okay. Okay. All right, tell me when you have it. You do a calculator handy, that's even better. 6 for, let's see, I got 4 times 6 for A, right? So that's 24 points here. 24 plus 2, because that's 1 point, right? We got 24, 25.6, and then another 3. 27, 28, 29. I got 29 for A. We're good? Maddie, what'd you get for C?
30.
30 for C. Working on, okay. And Jasmine, tell me when you got that one. 20?
No, it is 80.
Okay, sorry. Growing old, ears are going first. 24. 24 for B, okay. Now let's see, 3 times, that's 18 right here, right? 18 plus 8. So it's 4 times 2. 18 plus 8 plus 2 plus 6. So 18 plus 8 plus 6. Yeah, cool. All right, Jasmine, what'd you get? Count it together. You got 9? No, okay, that's fine. Let's do it together real quick here. So 6 times 1, right? Because it's on the bottom of the barrel over here. That's 6. 6 plus 2 times 2, which is 4. That's 10. And 3 plus times 3 is 9. So 6, 0.49. Is that right? Cool. Okay, let's see if we got it right. A is 29 points. B is, did we get 32 or no? Okay, 30 for C, 19 for D, is that right? So let's go back up here. B we got wrong. 3 times 6 is 18. 18 plus 8 is 24.
Oh, yeah. Oh, that makes sense.
No, 18 plus 8 is 26. 26, thank you. There it is. 26 plus 6 more would be 32. We good? You
Yeah.
good? Okay. So candidate B is the winner of the Borda counting method. However, candidate A has 6 of the 11 votes, which is a majority, beats all the other candidates in the head-to-head comparison. So that is candidate A is a Condorcet candidate. Okay. Are we good? Let's see. Should you write this down somewhere in your notes, right? So, pairwise comparisons, right, equals Condorcet candidate. So how do you find the Condorcet candidate? You have to do pairwise comparisons. Okay, that's one way to do it, okay? Next way to find a Condorcet candidate. So Condorcet candidate by pairwise comparisons, right? The other way a Condorcet candidate happens is that it has the majority vote. So however, candidate A has 6 of the 11 votes. The majority, so let's go back up here. So right over here, that's 5 votes here, right? It has 6 votes altogether. There's 11 votes here. So because of that, A is the Condorcet candidate. Oh, we're good. So 2 different ways. Condorcet candidate, either they have the majority of everything, of all the votes, as the first place, or you do pairwise comparisons. Okay, are we good? Let's jam. Let's do the homework in 7 minutes here. So this is your homework here. It says table 42 to illustrate why the plurality vote violates the 4th criteria. Kind of gives you a little hint as well. Okay, this is what you probably should do. If you want to just put down 53 on your notes, that's fine too. I don't expect you to copy down the whole entire table. And what I think what they mean is plurality method with elimination. I think that's what they're trying to say, not just plurality method. Right? Because plurality method, you look at it and say, oh, R is the winner, done. So find the winner, then eliminate F, and see what happens. So find the winner initially. Are we good? So let's real quick. Let's go back to what the criteria is. The last criteria. Here it is. The independence of irreverent alternatives means this. So if you have a winner candidate, and you said that's the winner, you can't structure anything in which if you eliminate the other candidates, another winner shows up. Okay. If the winner shows up first, eliminating any other candidates should still produce the same winner. Good. So now let's go for it. We're here, right? So real quick here, the winner is, by plurality method, R, right, with 49 points. Done. Okay, let's leave that alone. Winner originally here. So then who's the loser? F is the loser initially. F is the lowest loser, right? So let's do this here. Let's just eliminate F all of a sudden. That goes away. So now we only have 4 candidates, right? So can you make a table real quick? I think we have enough time. Can you make a table real quick here? Just eliminate F here, here, here from the process, and make another table that does not include F anywhere there. Just underneath. I think that'll be easy enough, fast enough for us to do. I still say 53. I think there's a, yeah, it should be, will illustrate why the plurality with elimination violates that. Even without even distributing points to the second highest person. Still. Percentages. Okay, are we good? Everybody made a table? Let's see. So, plurality method, R is the winner. The winner of this election is R. Using plurality. Now, F is clearly the non-winner. Removing F gives you this little shorter list. Are we good? So, real quick here, is that what you guys got? Is that the same thing? Can you give me the winner now? H is the winner, yeah. Looking at first choice only. Now, this guy has 51% of the vote. This one now only has 49% of the vote. So a different method is there. So in a recount, kind of H would be the winner using the plurality method. This is a violation of independent of irreverent criteria. Are we good? Okay, does that make sense? Okay. I think it's probably just difficult to keep all the different criteria straight in your mind and what you need to do against them. Okay, one last one with a couple minutes left. Explain why the method of pairwise comparison satisfies the Condorcet criteria. And we'll just I'll give the answer here. Let's see if this makes sense for us, okay? And this is the last of the homework assignment for chapter 1. So explain why the method of pairwise comparisons actually satisfies the Condorcet criteria. So let's take a look at it here. So I didn't want you to struggle over this, right? So a Condorcet candidate, by definition, is the one that wins every pairwise comparison, right? And therefore, it's going to be the winner underneath that method. Okay? And that's what I said in the beginning, right? There's 2 ways to do. Either it's the majority winner, the Condorcet candidate, or pairwise comparisons gives you the Condorcet candidate. Okay, so it's really a definition thing. Okay, are we good? And are we done with the homework for chapter 1? Okay.